Okay, we ever take an algebra problem from the Berkeley Math Tournament, problem number 2. We have the quadratic x squared plus 20x plus c equals 0, and we're given that the roots to this polynomial are m and we're given that m over n plus n over m equals 98, and we just need to solve for the square root of c. So we have this pretty complicated setup with a lot going on, but everything about it makes me think it's one of these problems where we should use Vetas formula, where maybe we don't need to actually solve, I mean, especially where we have c here, we don't necessarily need to solve for the roots individually, but with Vetas formula, we can get the product of the roots and the sum of the roots. Okay, so we have our Vetas formula over here to the left, assuming, again, roots are m and n, so the sum of the roots, m plus n, is going to be minus b over a, where the polynomial is in this form. So like in our example, b is 2020, a is going to be 1, and c is just going to be c. And the product of our roots, m times n, is going to be just c over a. Now in that case, where a is 1 and c is just c, so in our problem, this m times n is just going to be c. And then we can get this value as well. Again, a is 1, so this is going to be easy. The sum of the roots is going to be minus 2020. So next what I want to do is, they've given us this formula right here. I think this is going to be the key to getting some kind of solution out of this. So what I can do to manipulate this, I don't really like it in this form, so it doesn't really match with anything we have here. We want to be able to use the things we know, the sum and the product of the roots, not dividing the roots. But what we can do here is get a common denominator. If you do that, like basically just, if I multiply by m over m here and n over n here, this becomes m squared plus n squared over m times n. Well, even though we don't have a numeric value for m times n, we know it's c, so we can kind of just replace that with c. And we don't have this value for m squared plus n squared, but we can get to that because we know this with m plus n equal to that. So we know if I take m plus n and just square it, right, square it out, this is going to be m squared plus n squared, which is good, that's the thing we need right there, 2mn. Then we square this piece. The minus sign's not going to matter. This is going to become 20 squared. Well, m times n we determined earlier is just c. So this piece right here is 2c. So rearranging this, isolating m squared plus n squared, we get m squared plus n squared is going to be 20 squared minus 2c. So let's take this value right here and plug it back in for m squared plus n squared. Now taking this and going back to what we're given, we're told that this whole thing is going to be equal to 98. So we'll use that in a second. But now here what we can do is break this up into two fractions. So what I'll do is we'll have it as 20 squared over c. And then here, if I divide c into the second term, we're just going to end up with minus 2 equal to 98. Well, I can take this minus 2, if we just add 2 on both sides, then this goes away. And then on the right side, we have 100. So let me just bring this over here where I have some space. So what we're left with is going to be 20 squared over c is just equal to 100. So I think we're almost there, but again, remember our goal is to find the value for square root of c. Now that's not too bad, because I can do, if I take a square root on both sides here, square root on both sides. So then on the left side, what we have is just 20 over square root of c. That's nice. This just becomes 10. If I divide by 10 on both sides, divide by 10 here, this just becomes a 1. Next, just multiply both sides by square root of c. Multiply by square root of c here. This is going to cancel. Now we've solved for square root of c. Divide 10 into 2020, and for my final solution to this, we get just 202. There you have it, good algebra problem from the Berkeley Math Tournament. Thanks everyone for watching. Have a good day.